Hi, welcome back to week 2. This week we will be looking at what the ozone is and the issue of ozone layer depletion, and then we will also go over how to analyze an article. So if you're reading articles for your discussions and for your papers, look at some techniques to use when you're analyzing the articles. So in week 2, we'll start looking at one of the first issues that we are going to discuss in the discussion forum. And your goal in these discussions is to provide you with a deeper understanding of the topic to prepare you to write a paper on one of the issues. So you'll be doing 2 papers in the class. So you'll be picking 2 different issues to do papers on. And the first paper down here at the bottom will either be on ozone depletion or climate change, which are your week 2 and 3 topics. And in the discussion this week, you'll be looking at ozone, what is the ozone and ozone layer depletion, what's being done and still needs to be done, and any factors that are important to promoting or hindering success, such as cost or educational needs. So the specific topics in the discussion in the paper that you'll look at is, first, I'd like you to just describe what the issue is. So what's the problem and why exactly is it a problem? So everyone's going to discuss that in the discussion. And then in the discussion for the week, you'll choose one of these 3 things to discuss. So either the long and short-term implications of not dealing with the issue, where the issue is the most significant and why it's significant there, and then possible solutions to this problem and the economic costs and educational requirements to implement the solution. So you'll be discussing all of these in your paper, but for the discussion, you'll be choosing one of those to discuss on your initial post, and then hopefully different people will post on different things. You may want to choose to post on something for the discussion that you're not as familiar with. So if you look at these 3 issues and look at what you're very familiar with, you may want to choose to post on something you're not as familiar with so that you can learn a little bit more about it for your paper. And then you'll reply to 2 different students. You can add more information to what they've added. Not looking for the replies, just I agree with what you said. You can certainly say that, but really looking to build information, because again, the point of the discussions is to prepare you to write your papers and have you have a lot of good information going into the paper writing so that you can write a good paper looking at the issue. So again, your first paper you'll be doing during week 4, and you'll be either doing the paper on ozone depletion or climate change. But either way, everyone will do the discussions on all of the topics, but then you'll choose one of those topics to do your paper on. So I'm going to get into the issues of the ozone and ozone layer, and if you have any questions when you go to do your discussion, don't hesitate to ask. Start out by looking at ozone and ozone layer depletion, and the satellite there is a picture of an ozone monitoring satellite. So let's start out by looking at what is ozone. And ozone starts out with oxygen molecules that are in our air and our atmosphere. And oxygen is simply O2, or 2 oxygen atoms hooked together. So you have one oxygen atom, another oxygen atom makes up an oxygen molecule. And when that oxygen molecule is hit with sunlight, the energy from that sunlight can break apart the oxygen atoms and break it apart so that one oxygen atom separates, and that oxygen atom can then attach itself to an oxygen molecule. And so where you used to have 2 oxygen atoms, now one of those atoms has moved over and created O3 instead of what you used to have, O2. This is a naturally occurring process that just happens with any oxygen in the air. And when you get that O3, then we call it ozone. So there's our O3 for ozone. Now the ozone layer is a layer of concentrated ozone. Ozone can be found anywhere. The ozone, or those 3 O3 molecules, can be found anywhere in the atmosphere, but it collects and is primarily, or most of it, about 90%, is found just above the troposphere in the layer that we call the stratosphere. This layer occurs about 6 to 30 miles above the Earth's surface. The ozone layer has a really important function, and the sun, as you may know, emits many different types of light, and most of this light is a lot of this visible spectrum is necessary for life on Earth as we know it. So it helps plants grow, it gives us heat and energy, and the light from the sun obviously is really important. Some of the sunlight rays that are harmful are the ultraviolet radiation, and ultraviolet radiation comes down from the sun, and one type in particular, UVB, can do a lot of damage to living things, and the ozone layer functions to those O3 molecules will absorb the UVB radiation, and the thicker your ozone layer is, the more of that UVB radiation that will be filtered out. And so that UVB radiation gets absorbed here in this layer, which is important not only because it protects the Earth from not getting that as much UVB radiation, but it also, absorbing all that UVB radiation, it's absorbed in the form of heat. And so this ozone layer warms up and it helps heat the Earth. So ozone can play a really important role in the temperature structure of the Earth's atmosphere, as well as filtering out the harmful UVB radiation. I'm sure you've all heard that UV radiation is bad. Some things that UV radiation can cause that I'm sure you've all heard of are skin cancer. It can also lead to increase in cataracts and a suppressed immune system. And the United Nations Environmental Program estimates that if there's a 1% depletion of ozone, it will lead to a 2 to 3% increase in the incidence of non-melanoma skin cancer. Increased UVB light also will inhibit plant growth and makes plants more susceptible to disease. So not only will it make animals more susceptible to disease, but it will make plants more susceptible to disease as well. And they've noticed that phytoplankton in the Antarctic have a 6 to 12% reduction in photosynthesis, apparently due to the ozone hole there. And phytoplankton are really important because they're the base of the marine food chain. So if we start seeing them decreasing, we can expect to see animals all throughout the food chain decreasing. The figure there on the right shows a monitoring station for UVB radiation, and they have the U.S. Department of Agriculture has these across the country to monitor how much UVB radiation is hitting the Earth's surface. So ozone, as much as it has a really important function in the upper layers of our atmosphere, in that stratosphere, it is not good when it occurs lower down in the atmosphere. So atmosphere in the troposphere ozone in the troposphere would be what we call smog ozone, and it can have a toxic effect on humans and vegetation. So we don't want an increase in ozone everywhere. We don't want an increase in ozone in this layer above the Earth, but we do want the ozone in this layer here. And that's just to point out that just because you see the word ozone, don't always assume that that's a positive term. Depends on where the ozone's located. Let's look at what's been done regarding ozone over the past few decades. So in 1974, two scientists, Sherwood Rowland and Mario Molina, discovered that substances called CFCs can break down ozone in lab experiments. They were just doing lab experiments. They realized that these chemicals are breaking down ozone. By 1978, the U.S. had banned CFC use in aerosol cans, and then by 1984, they finally discovered the seasonal hole in the ozone over Antarctica. By 1987, they got together, the UN created the Montreal Protocol, which is an international treaty, and they agreed to try to reduce the use of CFCs. So let's look now at what exactly these CFCs are that we're talking about. So in the 70s and 80s, they noticed substances these substances they called ozone depleting substances that rapidly break down ozone. And one of these types of substances are chlorofluorocarbons, or CFCs. And CFCs were commonly used in aerosol sprays such as hairspray and blowing agents for foam and packing materials. They were used as solvents and as coolants in refrigerators and air conditioning systems. The picture there on the right shows the Halley Research Station in Antarctica, which is where they first noticed the hole in the ozone layer. Let's look next at how chlorine atoms work to break apart ozone. So the first step that you need is you need to have these CFCs in the atmosphere. And solar and ultraviolet radiation, when they hit these CFCs, can break off one of the chlorine atoms. And so you get this molecule over here, and you get the chlorine atom broken off. Now, if this chlorine atom collides into an ozone molecule, it will steal one of these oxygens, and it will create then a normal oxygen molecule, O2, and it will create this chlorine monoxide. Now, the newly formed chlorine monoxide can break apart, and the chlorine atom can come off, and it can go then hit another ozone molecule. And it can do this process over and over and over again, so it sets off a chain reaction. And one chlorine atom broken off can break down up to 100,000 ozone molecules. So that just one CFC in the atmosphere can do a lot of damage to the ozone layer. Now, you need a few special things to create what they call the recipe for ozone destruction. And you need high levels of chlorine or bromine. So you need that those CFC type substances or ozone depleting substances in the atmosphere. And they estimate that 80% of the chlorine over Antarctica is from human sources. So there's some naturally occurring chlorine in the atmosphere, but most of it's from human sources. And you need extremely cold conditions. So you need temperatures about -80 degrees Celsius to release the chlorine from the chlorofluorocarbon. So if you have warmer temperatures, then you're going to see an increase in ozone, and you'll see the ozone hole actually decrease. If you have colder temperatures, then the ozone hole can increase because ozone decreases. And you need sunlight, so you need energy for the chain reaction that allows one chlorine to destroy thousands of ozone molecules. So the sunlight provides that energy for the reaction to occur. So you do need that sunlight energy, but you also need it to be extremely cold. So the ozone hole occurs when 100% of the ozone in that area is destroyed. So if you destroy all the ozone within that region, then you will get a hole in the ozone layer. Now, the ozone hole only comes around when you get some sunlight, which in Antarctica happens in what we would consider late summer here. So in those late summer months, Antarctica gets a little bit of sunlight, but high above in the stratosphere above Antarctica, it's really, really cold. So you get the cold temperatures, you get a little bit of sunlight, and if you add those chlorine atoms from the chlorofluorocarbon, then you can get ozone destruction. There are lots of different types of ozone destroying substances. A good website that I think is pretty brief but has some good information is this website here. So if you want to click on that, you can get a list of all these different ozone destroying substances. And some of these are, as we've been talking about, chlorofluorocarbons, which are a group of chemical substances that contain 1, 2, or 3 carbon atoms and at least one atom each of chlorine and fluorine. There are hydrochlorofluorocarbons, and the hydrogen on those, this word hydro means it has a hydrogen on it, makes them less stable and therefore less damaging to the ozone. They're used mainly to replace these CFCs, which are very damaging, until a non-damaging solution is in place. They have only about 2 to 5% of the ozone depleting potential as CFCs do. Another type of ozone destroying substances are methyl bromides. And 1990s, agricultural industries were using 70,000 tons of methyl bromide as a fumigant to control agricultural pests. They agreed to phase these out in the Montreal Protocol, and they were scheduled to be phased out by developing countries by 2015. Halons are another type of ODSs. They were first used as fire retardants and have the worst ozone depleting potential of all these ozone destroying substances, and they were supposed to be phased out by developing countries by 2010. Developed countries no longer produce them, but many of them may be pulling from stockpiles that they already had and using them. And again, this reference here is good, goes into a little bit more detail about each of these and what the developed and developing nations were supposed to be doing in terms of phasing them out. So if you remember, in 1985 was when they first discovered that there was actually a hole in the ozone. And at the 1985 Vienna Convention, they established mechanisms for international cooperation and research into the ozone layer and the effects of ozone depleting substances. The protocol called for parties to phase down or phase out the use of these ozone depleting substances. After a series of rigorous meetings and negotiations, they came up with the Montreal Protocol on substances that deplete the ozone layer. And they finally agreed on the Montreal Protocol on the 16th of September 1987 at the headquarters of the International Civil Aviation Organization in Montreal.
and it was signed by 24 countries and by the European Economic Community. And as the former Secretary General of the United Nations said, perhaps the single most successful international agreement to date has been the Montreal Protocol. So moving forward, the United Nations has met many times discussing the issue of ozone depletion, and at their latest meeting in 2014, they put together a synthesis report, which I would really recommend you read for information for discussing your issue. I just want to go over a few of their main points at the end of their report, and some main points that they made are, as we know, the ozone layer is fragile. If you compressed it to sea level pressure and standard temperature, it would only be 3 millimeters thick, and the impact of only a few parts per billion of potent ozone depleting substances could be devastating. Their experience over the last few decades is that it can be damaged by human actions within very short timescales, and the sustained success of the protocol hinges on continued vigilance by the parties to fulfill their commitments. So the countries that said they needed to phase out certain ODSs by certain dates need to fulfill that, and future actions that threaten to nullify the ozone and climate benefits achieved under the agreement, they should make sure that they work to fulfill these agreements. Success also depends on continuing the lessons of collaboration, leadership, innovation, and shared investment in our global environment that was the promise made to future generations under the Montreal Protocol. Now, if you're looking to this week and what you need to be discussing, as I mentioned, this is a great article overviewing what was found in 2014. Scrolling through that and getting some information through that would be a great start. You're welcome to go get any of your own other sources that are good, reliable sources as well. And some things that would be good to consider is, has there been anything new learned since this document in 2014?
So a lot can change in 4 years. So is there anything new that we've learned in that time frame that we need to take into consideration? And have the countries been following through with the proposed scheduled changes? What the cost of the most recent proposed changes are, changes that may be needed. So cost is one really important factor in looking at something, if it's something that is doable. And then lastly, what are the current ODSs being used, and does the public still need to be educated on their use? So those are all some things that, as you're preparing for the discussion and as you're reading your articles, you can keep in mind for the discussion. So here's two of the resources that I've mentioned. Here are the United Nations Environmental Program Synthesis Report, and that's that link here. I'll also put these links to these in the Week 2 information page, and the Montreal Protocol reduction plan for each ODS. So this is some good information at this site here. This is a lot more detail, it's a little bit more brief, but those are two good resources that you can use when you're preparing for your Week 2 discussion.
Next, we're going to move on to how to analyze an article. So if you're looking up information, some things to look out for and be aware of as you're reading that article. So in this section on analyzing an argument or analyzing an article, we'll look at what you should look for when you read an argument for an issue, and then what makes someone's argument bad. To help us determine which argument is better, we can ask a few questions. We can look at how empirical is the presentation, so how empirical in terms of scientific data. What is fact versus what is opinion? What is the propaganda that's being used? What cause and effect relationships are proposed? Are the cause and effect relationships merely correlations? Is information distorted? Are analogies faulty? Is the author oversimplifying the issue? Is the author stereotyping? And are there faulty generalizations? So we're going to look now through each of those in more detail. So one of the really important things to look at in the beginning is how empirical is the presentation. So the best argument supports its ideas with evidence. So look at the credibility of the author. Is the author a credible person that has good credentials? And is the material up to date? So looking at, is the information still relevant that you're reading, or has new information possibly been found since then? Another important thing to look at is what is fact versus what is opinion. A fact can be proven. An opinion expresses how someone feels about an issue or what they think is true. Many authors will blend fact and fiction, and so that's one of your goals in reading something, is to try to separate fact from fiction. Facts are determined from research and should carry the most weight. Opinions should carry less weight when evaluating an argument. So an author who is very, very credible, you might take their opinion a little bit more with a little bit more weight, but again, tying in the credibility of the author and really trying to look at facts as your primary source of what you think. Something else to look at in an article is what propaganda is being used. Propaganda is information that's presented to sway the reader. It's not necessarily good or bad, but it's a good thing to be aware of. Looking at the author's background or motivations, who are their studies funded by? Do they have some other motive for wanting the information to be seen in one way or the other? Is a good idea to look out for. And is the information distorted? So don't be overly impressed by statistics. If they say most Americans believe that, um, why say most when a simple survey could give a more accurate percentage? So at most maybe 51%, which is not that convincing. So try to look at words like most and other things, and instead of looking at those words, look for the percentages. Look critically at those numbers. Another thing to look at is what cause and effect relationships are proposed. So cause and effect means one thing causes another. Correlation means two things happen together but aren't necessarily caused by each other. So look for any proposed cause and effect relationships and determine if they are actually one thing caused the other or if they're just a correlation, they happen to occur at the same time. And are the cause and effect relationships merely correlations? For example, birds fly south in the winter because it gets cold. Cause and effect, the cause is it gets cold, the effect is so the birds fly south. The correlation is birds fly south when it's cold, but we don't necessarily know that they fly south because it's cold. Maybe they flew south because of decreasing food source, because of breeding instincts, or because birds just want a change of scenery. So this is just an example, but don't just assume because birds fly south in the winter, it's because of the temperature. Look at whether it really is temperature or whether other things maybe are just a correlation. Another thing to look at is, are analogies faulty? Analogies make comparisons between a known event and a similar event. For example, event A leads to outcome X. Event A is like event B, therefore event B leads to outcome X. Analogies usually ignore important differences between the two events. So an example would be DDT is a pesticide. DDT was banned due to its harmful effect on the environment. And Roundup is a pesticide, so Roundup should also be banned. So just because both things are pesticides does not mean that both things have equal negative effects. You need to look at, that would be an example of an analogy, trying to say that things are similar, so we should have the same outcome for both of them. Another thing you can look at is the author oversimplifying the issue? If the author only focuses on their position and not the other position, they may be oversimplifying. So look out for general statements without information to back it up. For example, simply stating clear cutting is detrimental to the environment, it might be better to say clear cutting has caused these problems, and the opponents would argue such and such. So someone who is looking at both sides is not as likely to be oversimplifying their case. Another thing you can look at is the author stereotyping. It's similar to cause and effect or analogy problem, making comparisons to two things because they're similar, but one may or may not cause the other. And are there faulty generalizations, which may occur when only one set of research is used to imply that something is true, when other research is ignored or needs to be done. Don't rely on a few random events to prove something. So good statistics would use a broad research set with a lot of numbers, a lot of data, and not just focus in on one small set of research that may not be good research. So the last thing to look at when you're reviewing something is for different types of propaganda. These would include, and I'll go over these in detail in just a second, generalizations, name calling, emotions and persuasion, appeals to fear, appeals to hatred, appeals to pride, slogans, pseudo-solutions, and presuppositions. So let's go ahead and look at those. So first, generalizations would be, for example, acting as if a company or a group is a person. And this would be, for example, saying the drug company failed to act on something, causing numerous deaths. This sounds not so bad, but the problem is that the drug company is not a person, it cannot act, and it can't act or not act. So a single person may be responsible, but the insinuation is that the whole group is bad. And so you need to look out for that type of generalization. Name calling is another example of propaganda. It may focus on character of someone rather than the validity of their work. So you always want to be looking at whether the work looks scientifically sound and not necessarily, although it's good to take into account the person doing the work, Character isn't as big in terms of, unless it's character that they're not doing scientifically sound work, but you want to look at the quality of the work as your main thing. Another type of propaganda is emotions and persuasion. Some appeals to emotion may be based on genuine feelings of the writers, and others may be crafted to try to persuade you. Be aware to plays on emotion as you read. Look for proof, not opinion. Appeals to fear, hatred, and pride. They may use words like underhanded, extremists, may build fear or hatred to try to persuade you, may try to persuade with pride as if any educated person knows that. So those appeals can be used to try to make you think that you should be feeling one way or another. And again, you're always looking at the facts. Slogans may mean different things to different people, like save the environment may sound good, but what they're proposing may or may not actually be good. So instead of assuming that when they say save the environment, they're doing something good, look at what they're actually doing. Pseudo-solutions and presuppositions. A solution that can't fail would be an example of a pseudo-solution. People are throwing trash on the ground. The pseudo-solution would be motivate the people to clean up. That's not really a solution because what are you actually doing to motivate them? So that would be a pseudo solution. The real solution might be to impose littering fines or something else, but something that you can actually act on. A presupposition is information that you assume to be true, but may not actually be true. So again, if you read something or want to state something in a discussion, make sure that there is data to back that up and don't just assume that something is true because you have always thought it is true. The big picture would be to keep in mind that these techniques are not always good or bad. Analogies may be useful, cause and effect may be valid, etc., or they may not be. But do be aware that there may be problems with the techniques discussed above. And don't feel that you have to address all of these things as you look through an article, but just keep these in mind as you read something and are trying to determine whether an article is a good source of information that you see in an article is good information.
That's the end of our week 2 lecture. You're now ready to start preparing for your week 2 discussion. And please let me know if you have any questions as you get started with that.